Simplify the following rational expressions. State all non-permissible values. In order to simplify a rational expression, we first need to factor both the numerator and denominator if they are not already in factored form. We can do this by first factoring out a greatest common factor. We can use trinomial factoring if we have a trinomial, or if we have a binomial that is a difference of squares. We then cancel out any factors that are common to both the numerator and denominator. The resulting simplified form is identical to the original expression, except the original expression has undefined values of the variable that correspond to the canceled out factors. As an example, if we have x plus 2 times x minus 1 over x plus 2, we can cancel out the x plus 2's. This then is equivalent to x minus 1, except x cannot equal negative 2. The non-permissible values are values for the variables for which the expression is undefined. We have to apply this before any cancellation of the factors. Look for values that make the denominator equal to 0. For the example that we've just done, note we had canceled out the x plus 2's. In this case, the x plus 2 cannot equal 0, so x cannot equal negative 2. Again, note that we had to look at the expression before we canceled the x plus 2. For the first example, x squared minus 2x minus 8, the numerator, can be factored to x plus 2 times x minus 4. The denominator is a difference of squares. X squared minus 4 factors to x plus 2 times x minus 2. Note we have common factor of x plus 2 on the top and bottom. We cancel that out. Then the final result is x minus 4 over x minus 2. For the non-permissible values, we look to what we had before we canceled out the x plus 2. This means that x cannot be negative 2 or positive 2. For b, in this case, we look at the numerator first, a squared plus 5a plus 6. We can factor that to a plus 3 times a plus 2. The denominator, we first factor out the 2, which is the greatest common factor. We can then factor the a squared minus 3a minus 10 to give a minus 5 times a plus 2. Note now that the a plus 2 is common to the numerator and denominator. We can then cancel that out. That leaves a result of a plus 3 over 2 times a minus 5. Again, looking at the expression before we canceled the a plus 2, we can have a not being negative 2, because that would make a plus 2 equal to 0. And a cannot be 5, as that would make a minus 5 equal to 0.